Hello. All right, so we have reviewed how to simplify radicals. Now we are going to look at how to use radicals when solving. So this method is going to be solving by square roots. So we have x squared. Our x squared is isolated. To undo squaring something, we're going to take the square root. Now we break it down because we're taking the square root and we know how to simplify those radicals. When I'm breaking down our 72, we've got 2 and 36. And I did that because I knew 36 was a perfect square, 6 and 6. Maybe you didn't know that. You didn't see that relationship right away. It doesn't matter. When you break it down in the end, you still end up there. Now, though, when I'm solving for this, there's something a little bit extra that we need to add in. This becomes x equals plus or minus 6 root 2. When we are solving by square roots, we need to add in that positive negative. Because when I was going to square this number, let's use an easy example, x squared is equal to 9. I don't know what number this is. This is an unknown value. I could have squared 3 to get 9, or I could have squared a negative 3, and I also would have gotten a positive 9. So when you're squaring an unknown value, you don't know if it was a positive number or a negative number because when you squared it, it got rid of the negative. So when we are solving by square roots, we need to add in that plus or minus sign. Number 2, we're still going to solve for that square root, but this is the quantity being squared, x plus 5. We need to get the squared quantity isolated alone. So we're going to move everything else over. And in this case, what was attached to it was a 2. When I divide by 2, we get 16. We take the square root because the x plus 5, that's locked inside of that squared quantity. And when I take the square root of something was the being squared, that becomes plus or minus 4 because 16 is a perfect square. And then we move it over. What you want to be really careful about is we're not going to leave this as our answer. This is like telling me your answer is 2 plus 2. Just tell me it's 4. These two pieces are like terms. We have two different possibilities here. We have a negative 5 plus 4, which gives us a negative 1, or we have a negative 5 minus 4, which gives us a negative 9. So we have x equals a negative 1, or x is equal to a negative 9. So when you have like terms like that, make sure that you go that one extra step and put the like terms together. Our next one, we move our 4 over, because remember, this is being trapped by the x squared term. We want to isolate the piece that is being squared. We move the 4 over first, just like we were solving a normal equation that wasn't being squared. Then we divide by the 3. Now that we have the squared quantity all by itself, then we square roots. Now the other two we were able to break down, but if you try to break down 7, that's just 7 and 1, which is okay. Sometimes you can't break it down. So this becomes x minus 2 is equal to plus or minus the square root of 7. The step that you take the square root, that's the step that you put that plus or minus in there. And then we move the 2 over. So the last problem, I said make sure you put them together. I said make sure you put them together because they were like terms. These are not like terms. We have one with a radical and one without a radical. So you've got a root 7, there's our radical, and there's our answer. Now this is two different answers. It's 2 plus root 7, and that's 2 minus root 7. You can write them separate, or you can write them together. It's completely up to you. I always write it together because I'm lazy and it's less work. All right, our next one, number 4. Again, when we solve by square roots, our goal is to get our x squared term isolated. We move our 10 over. 2x squared is equal to a negative 8. We keep on solving to get that x squared by itself. X squared is equal to a negative 4. We square root. When we go to square root, we notice something, and we can't forget this. When we have that negative on the inside of the radical, remember, that means imaginary. If you had a really good math teacher for Algebra 1, they didn't tell you write no solution when you had negatives under the radical. They taught you to write no real solution. Because there is a solution, it's just imaginary. So this becomes x equals plus or minus 2i. Because the square root of 4 is 2, but the negative makes it an I. Because I was solving for an unknown value that was being squared, it's plus or minus 2i. And our last one, still same idea. We want to get this x squared by itself. So we move our 3 over. X plus 2 quantity squared is equal to a negative 12. We square root each side. We see that we have that negative underneath that square root again. So when I break down the 12, after you do these radicals enough, you're going to start knowing what they are. Like you're going to know that the square root of 8 is 2 root 2. Maybe you'll know that 12 is 2 root 3. You don't have to show me the work of the factor trees. You just have to get to your answer. So because of the negative, this becomes a 2i, plus or minus 2i root 3. Because we were solving for that unknown value that was being squared, we still need to get x by itself, so we move the 2 over, and x equals a negative 2 plus or minus 2i root 3. Remember, you only want to add the pieces together if they are like terms. These two things are not like terms. One is a real component and one is an imaginary component, and that imaginary component has a radical. So only put things together that are like terms. All right, that was our solving by square roots video.